Greetings to Madam Lisa. Today, my groupmates and I will be presenting our optimization project based on a selected queuing system. So, our YUVIN THARAN anak lelaki BALU BS 19110137 will be beginning by giving the introduction to a selected queuing system. Queuing theory is the mathematical study of queuing or waiting in lines. Queues contain customers or items such as people, objects, or information. Queues form when there are limited resources for providing a service. For example, if there are 5 cash registers in a grocery store, queues will form if more than 5 customers wish to pay for the items at the same time. A basic queuing system consists of an arrival process, which is how customers arrive at the queue or how many customers are present in total. The queue itself, the service process for attending to those customers, and departures from the system. Mathematical queuing models are often used in software and business to determine the best way of using limited resources. Queuing models can answer questions such as what is the probability that a customer will wait 10 minutes in the line? What is the average waiting time per customer? That's all for my part. My introduction will be continued by HAFIZ. Thank you.
My name is Muhammad KHAIRUL HAFIZ bin ABDUL HALIM, BS 19110244. Today is my presentation. As we can see here, the following situations are the example of how queuing theory can be applied. Number 1, waiting in line at a bank or a store. Number 2, waiting for a customer service representative to answer a call after the call has been placed on hold. Number 3, waiting for a train to come. Number 4, waiting for a computer to perform a task or respond. And the last one, number 5, waiting for an automated car wash to clean a line of cars. Next one is some of the picture that we all take when we do our survey at the service center building and our picture of interpretation of our queuing system that is used at our service center, that is McDonald. That's all from me. I pass to the next presenter. Thank you.
Assalamualaikum and hi, my name is ERNISAL bin SALLEH, metric number BS 191100269. I will continue in part of description of the characteristic of the selected queuing system. The first is rival characteristic. The size of the calling population is finite. For example, McDonald will only receive 3 self-order at 3 counter at one time because of limited workers. The pattern of arrival at the system assume for arrival at service facility follows the Poisson distribution. For example, 30 customer per hour. The behavior of the arrival is, the first one is patient customer, which is wait in the queue until they are served. Next is bulking customer, who refuse to join the waiting line because it's too long to suit their needs or interests. The last one is reneging customer, others who enter the queue but then become impatient and leave without completing their transaction. Next is waiting line characteristic. The length of line or queue is unlimited because McD or McDonald will open for 24 hours and no limit for customer coming. The queue discipline is FIFO, that is order in which customer are served, which is first in first out. For example, payment at counter at McD.
Hi everyone, I'm SAFIAN bin FAIZAL with metric number BS 19110082. I will continue the presentation on the description of the characteristics of the selected queuing system, which is the self-order kiosk at McDonald's. Let's start with the service facility characteristics. For the configuration of the service system, there are 3 servers at the first station and 1 server at the second station. Thus, it is a multi-channel system since there is more than 1 server being used. For the number of phases or the number of stations is equal to 3. Thus, it is a multi-phase system since there are 3 stops before leaving the system. Next, the pattern of service time. Similar to arrival patterns, service patterns are often stochastics. For multiple channels, the model involves the assumption of for service times follow the exponential distribution. The exponential distribution is the probability distribution that describes the time between events in a Poisson point process, that is a process in which events occur continuously and independently at a constant average rate. The basic queuing system configuration is multi-channel, multi-phase system. As we can see at the figure, it starts with the customer's arrival, and then the waiting customers, and then the first station, which is the self-order kiosk. There are 3 self-order kiosks here, and then the waiting customers again, and then the second station, the cash payment counter, and then the last station, pickup counter, and then the customer can leave the system with their foods. However, in this system, we only focus on the first station, which is the self-order kiosk. Thank you.
Hey madams and my fellow friends, my name is Yuji with matrix number BS1911032. Next, I am going to present about the calculations for the operating characteristic of our multi-channel queuing model. Before we start our calculations, we have to note that the assumptions for our models should be an infinite calling populations, arrival rate of customers in a queuing system is random that follows Poisson's distributions. The queuing system is in normal or stable conditions. We should identify the servers, unlimited queue length, a first-come first-served queue disciplines, service rate of customer with the service times follow and exponential distributions. We assume our lambdas, the average numbers of customers arrive in McDonald's per hour is 30, and our meals is equal to 22, which is the average numbers of customers served per hours in counters. As the slide shows before, in this project, we are only to analyze the first phase of our queuing model, which is self-order kiosk in McDonald's. Therefore, the numbers of servers is equal to 3. As logic, the total numbers of servers must be able to serve customers faster than they arrive, which as shows below. Next, we got 5/11 or 0.45 for the utilization factors. The probability zeros customers in system P0 is equal to 25%, which means there are 25% of chance for customer using self-order kiosk without queue. Besides, because LQ is equal to 0.16, which means there are at most 1 customer with waitings in queue. The average numbers of customers in the system L is equal to 1.52, which means there are at most 2 customers with waitings in queue and being served in the system. The average a customer spends total times in queue and self-order kiosk in the system W is equal to 0.051 hour, which is around 3 minutes. Last but not least, the average times a customer spends waitings in queue, WQ, is equal to 0.0053 hours, which is less than a minute. That's all from me. Thank you.
Assalamualaikum and very good morning. My name is Muhammad NURRUSYDI IZZAT. Proceed to the conclusion for this assignment. For the project overview, in this study we implemented the concept of multi-channel queuing model to determine how effective the waiting line or the queuing system in McDonald, One Borneo service and the customer satisfactions. By the corollary, the queuing system is high effective if the total number of the customer served is higher than the total number of customer arrived, which is the formula S multiplied with the mu is more than the lambda. From the calculation of this model, we consider the waiting line or the queuing system in McDonald's service is effective, which is equal to 66 customers served against 30 customers arrived. Observation from 5 types of customer and serve average, which are 0, queue, in system spending or the payment and the waiting. We found customers spend more time in system or can set, take order and the payment service within 3 minutes compared to the customer in waiting line which average within 1 minute only. The intensity of the customer be served is mostly higher than the arrive or in waiting line cause the queuing system in McDonald One Borneo is effective with 3 service counter, 30 customer arrive per hour and 22 customers served per hour. And of the study, we define almost of the customer who are coming to McDonald One Borneo are satisfied and happy with the service and the queuing system of the company. Thank you.